Hello everyone, in this video we will learn molarity and molality on mixing of solution. So we want to focus on mixing of solution. So before starting this, we should remember some rules of mixing. For example, to calculate concentration of ions present in resulting solution, obtained by mixing of two or more solution. Observe, number 1, if solutions having same solutes, if same solute containing solutions are mixed. If same solutes containing solutions are mixed, in this case we can find the molarity of resulting solution, that m dash v dash, that will be equal to m1v1 plus m2v2. What is actually this equation m dash v dash and m1v1 plus m2v2? Actually, we can explain this. Suppose we are having solution 1 of molarity m1 and the volume v1, and another solution of concentration m2 and volume v2. So when we are mixing this solution to get a resulting solution having the molarity is m dash and the volume is v dash, first of all we are assuming the solutions is ideal, so the v dash will be equal to v1 plus v2, so volume will be additive. While dealing with the problems related to the mixing of solution, in each case we have to find the moles of each species. So in this case we will calculate the moles coming from each solution. So the number of moles coming from first solution will be m1v1, and from second solution will be m2v2. So the total number of moles in the resulting solution will be equal to m1v1 plus m2v2. So these are the total initial moles. Yeah, we can say that these are the total moles which are present in the final solution. So we will divide this total number of moles by total volume, which is v1 plus v2. That will be equal to v dash, and that will be equal to, we can write the relation that m dash is equals to m1 v1 plus m2 v2 upon v1 plus v2. So we can say that we are in case of mixing, we are just putting the total moles equal to the total initial moles, while the solutes are same. Or we can also say that ions present in resulting solutions are not interacting with each other, which means that the ions which are coming from solution 1 and solution 2 are not reacting on mixing. So this is the case in which we can calculate the molarity like this. So ions present in the resulting solutions are not interacting with each other. What is mean by this? When solutes contains same cations or anions, these will not react. For example, if you will mix Al2SO4 whole thrice solution of a particular concentration, suppose 0.1 m 100 ml in 0.2 m LCl3 solution of volume 400 ml. So when you will mix these two solutions, right, and these solution will not react because the ions are non interacting in these, because the cations are same. So if we wish to find the resulting concentration of Al+3 and SO4-3 AlCl3 ions, we can easily calculate it in this solution by calculating the moles of indivisible species. So how we can work on this? We can take one more case in which on mixing of solutions, ions reacts or ions are interacting with each other. So when ions react with each other, for example, when strong acid and strong base are mixed, obviously some part of the acid and base will neutralize to give unionized water. So the concentration of H plus or OH minus ion in the resulting solution can be calculated as, this is acid and the concentration of acid is taken as Ma and the volume of acid is Va, and the concentration of base is Mb and the volume is Vb. So when we are mixing these acid and base and preparing a resulting solution, so obviously the acid, some part of the acid will be neutralized the base. So the moles coming from moles of H plus coming from acid is MaVa, and moles of OH minus which is coming from base will be MbVb. So this is resulting solution, and the resulting solution will either contains H plus or OH minus. The concentration of H plus or OH minus can be calculated as mode of MaVa minus MbVb divided by Va plus Vb. We have subtracted because some part of the H plus or OH minus ion will neutralize to each other. So the solution may be acidic or basic depending upon the MaVa, product of MaVa and product of MbVb, which are the moles of H plus or moles of OH minus. So what we can say, if MaVa is greater than MbVb, solution definitely will be acidic, and if MbVb is greater than MaVa, OH minus moles are more as compared to H plus, the solution will be basic. And if these are equal, H plus and OH minus ion moles are equal, the solution will be neutral. Right? So in this case the ions are interacting. One more example we can take in which the ions are interacting are precipitation reaction. Precipitation reactions. Obviously, precipitation reaction, for example, if we are mixing AgNO3 and NaCl, this is aqueous NaCl and aqueous AgNO3. When these are mixed, then definitely a precipitate of AgCl will be formed, and along with the NaNO3 aqueous will form. So the ions present in the resulting solution will be the ions which will be left if excess reagents are present in this, or the ions which will be formed. The ions which is present in the precipitate will not be counted in the solution. The ions which have gone into the precipitate will not be counted. In some examples of mixing. It is to be noted that when the mole volume is given in ml, so you must be careful about this, because m into v ml is millimoles, right? So let's start with the first example. 100 ml of 0.1 m Al2SO4 whole thrice is mixed with 100 ml of 0.1 m AlCl3 solution. As I told you in the last video that when cations or anions are same, they are non-interacting. So in the solution, ions will not interact. So in solution, Al plus 3 ions, SO4 minus 2 ions and Cl minus ion will be present. In the resulting solution, Al plus 3 ions, SO4 minus 2 ions and Cl minus ion will be present. So first we will calculate the millimoles of Al2SO4 whole thrice. So millimoles of aluminum sulfate Al2SO4 whole thrice will be 100 into 0.1, that will be 10 millimoles. And the millimoles of AlCl3, millimoles of AlCl3 will be 100 into 0.1, that will be 10 millimoles. Now if you wish to calculate the concentration of Al plus 3 sulfate and Cl minus ion present in the resulting solution, then how we can proceed? First, we will calculate how many Al plus 3 ions are coming from solution 1 and solution 2. Then we will add that, as we discussed in the last video, that in the mixing, first we will find the total number of moles of given species in the resulting solution. So the millimoles of Al2SO4 whole thrice is 10. So number of millimoles of Al plus 3 coming from first solution will be 20, as 10 into 2. In the same way, millimoles of Al plus 3 coming from second solution will be 10. So these are the total millimoles. So we will divide this by the total volume, which is 100 plus 100, which is 200 ml, right? So this will give 30 upon 200, which will be equal to 0.15 m. And it is to be noted that in the numerator we have put millimoles, in the denominator we have put the volume in ml, so we are not multiplying this by 1000. Now we can calculate the concentration of sulfate ion also. So from the second solution, sulfate ions are not coming in the resulting solution. From the first solution, SO4 minus 2 ions are coming. So how many millimoles of SO4 minus 2 ion will be in the resulting solution? It will be 10 into 3. So 30 divided by 200, 30 divided by 200, right? This will give 0.15 m. In the same way, we can find the concentration of Cl minus, as Cl minus is coming only from the solution 2. So the millimoles will be 3 into 10 divided by 200. Again, this will give 0.15 m. So on mixing of Al2SO4 whole thrice and AlCl3, according to data, the concentration of Al plus 3, SO4 minus 2 and Cl minus ions are 0.15 each. Let's take second example, 10 ml of 0.1 m HX. HX is mixed with 20 ml of 0.2 m H2Y. Assuming HX and H2Y gets completely ionized in their solution, calculate molarity of H plus in the final solution. So we will use the same concept. We will calculate how many H plus ions are coming from the first solution. So it will be 10 into 0.1 into 1, because HX will give 1 H plus ion, plus we will find the millimoles. 20 into 0.2, this is the millimoles of H2I, and this will be multiplied by 2 because 1 mole of H2I will furnish 2H plus ion. Now divided by total volume, which is 30 ml. On solving this, you will get 9 by 30, that will be equal to 0.3 m. This is the case in which the ions are non-interacting, right? So that's why we are finding the total millimoles and total volume. To find the concentration of required ions, we are dividing the total millimoles divided by total volume of solution. Let's take another example. It is given that 200 ml of 0.1 m Na2SO4 is mixed with BaCl2. So definitely this is the case in which ions will interact to each other. So some of the ions will be present in the form of PPT that will not be counted in the solution. So first we will write the reaction for that because the ions are reacting or interacting. So Na2SO4 aqueous plus BaCl2 aqueous, this will give 2NaCl plus BaSO4 aqueous. So at T equal to 0, if we will calculate the millimoles of Na2SO4, this will be 200 into 0.1, which means 20, and the millimoles of BaCl2 will be 200 into 0.2, that will be equal to 40. When they will react to each other on mixing, definitely Na2SO4 is limiting reagent, so it will completely consume. So for 1 mole of Na2SO4, 1 mole of BaCl2 will consume. So for 20 moles, 20 will consume. So the BaCl2 left in the solution will be 20. In the same way, NaCl will be 40 moles, 40 millimoles, and BaSO4, because this BaSO4 is present in the form of precipitate solid. So the ions which will be present in this BaSO4 will not be counted. Only the ions which is present in the solution phase will be counted. So definitely, if you will observe this data, then because 20 moles of BaCl2 and 40 mole of NaCl is present in the solution, so definitely we can say that millimoles of Ba plus 2, this is millimoles of Ba plus 2 present in the solution, that will be equal to 20. In the same way, millimoles of Cl minus, so obviously 1 mole of BaCl2 contains 20, so the Cl minus which is left in the BaCl2, that will be 40, means 40 will be left, and again 40 is forming because NaCl millimoles of NaCl is 40, so 40 plus 40, it will be 80. In the same way, millimoles of Na plus ions, that will be equal to 40. So if we will add all these 20, 80 and 140, it will make 140. It is to be noted that these 140 is millimoles, and according to the question, it is required to calculate the moles. So we will multiply this by 10 to the power minus 3 and you will get 0.14. If it is required to calculate the concentration of each ion present in the solution, we can also calculate that millimoles of Ba plus 2, suppose Ba plus 2 concentration is to be calculated. So concentration of Ba plus 2 will be equal to millimoles of Ba plus 2 divided by total volume, which will be equal to 400, right? So this is the way, this will be 0.05. So this is the way by which we can calculate the concentration of each ion. Let's take one more example in which the molarity of final solution is to be calculated. To be noted that this is the case when we are mixing the same solute. So in this case, as I told you that when same solutes are mixed, then the molarity of resulting solution can be calculated as M1V1 and M2V2, M1V1 plus M2V2 upon total volume, that will be 100. On solving this, we will get 0.5 M. In the second example, we are mixing the strong acid with a strong base. So in the mixing of strong acid with a strong base, definitely some part of the H plus and OH minus react to give unionized water. So in this case, millimoles of acid, which is half into 75 minus 2 by 10, definitely 1 by 10 into 25 divided by total volume, that will be equal to 100. On solving this, you will get 0.35 m. Obviously the millimoles of HCl is greater than millimoles of OH minus. That's why the resulting solution contains H plus ions and the resulting solution will be acidic. So thank you very much.